Hello and welcome to this video on translations of sine and cosine functions. The objective for today is that students will be able to find amplitude, the vertical shift, and period for sine and cosine functions. And the second part of the objective is to graph the said functions. However, I'm gonna have a second day in class where we'll go over graphing. So you don't have to worry about graphing. We're just going to talk about kind of the new word here, which is period. I mean, and you're aware that the period for these functions is 2 pi. However, we're going to adjust that for today. So prior knowledge, it says state the amplitude and the midline of each function, and then graph the function. Well, remember that the amplitude, that is your a value. So here we have a value of 4. So our amplitude is 4, right? This is amplitude, and we also have a k value, which is, I don't know why I wrote E. Our k value is -1, right? So our midline is y equals that value. Y equals -1, right? That would be your middle values. So for the second example here, right, our amplitude, our a values is -2, and the amplitude is generally the absolute value of this. So we have a +2, that's our amplitude, and our midline would be y equals 2. Okay, so just visually, I mean, this is how they look. But again, we'll talk about graphing in the next day. So I want to talk about period of sine and cosine. So you guys are aware that the period for these two functions is 2 pi. This is where they repeat themselves, but we're going to introduce a new idea, or a new transformation of a coefficient of our input, or our independent variable. So when I add a multiplier in front of the input, right, of theta or x or alpha or beta, whatever the variable is, we get a horizontal compression and stretch, which changes our period. So here y equals sine b theta, and y equals cosine b theta. So just notice that the b value is going to affect our period. So how do you calculate your period? Well, whatever your b value is, actually let me switch colors. Whatever your b value is, you're going, should I create a custom color? No. Let's go. Okay. So whatever your b value is, you're going to take that and you're going to divide 2 pi by that. So divide 2 pi by whatever b is. Okay? So just a general rule of thumb here, if your b value is a fraction, if b is less than 1, you're going to get stretch. It's kind of counterintuitive, right? You would think if b is bigger, then that would stretch it out, right? It's kind of the opposite of vertical stretch or compression. So if it's a fraction, you'll get a stretch, and if it is, if b is greater than 1, what we get is a compression. It pushes it together. Okay, and we'll look at some examples right now. So here is the first example. It says state the period for the function y equals cosine of theta divided by 4. Well, in this case, our b value is 1/4. So, and again, I know this, right, because there's an invisible 1 up here. So 1/4 is your b value. So to calculate the period, this is 2 pi divided by b, which in this case, 2 pi divided by 1/4. Okay, and oh no, a fraction, we're divided by a fraction. Very easy. You just take your numerator and you multiply by the reciprocal of the denominator. So 4 over 1. So 2 pi multiplied times 4, which is 8 pi. Okay, so your period's 8 pi. And this goes along with what I was saying, right? If your b value is less than 1, what you're going to get is a horizontal stretch. The period is now bigger. Okay, so here are some practice problems for you. I'd like you to, actually I'll do this one with you since we haven't done one of these. Here it says y is equal to sine of 4 theta. So what we have here is a b value that's 4. So to calculate the period, you take 2 pi, you divide by b, which in this case is 4, and we get 2 pi over 4. So this is going to reduce, right? So 1/2. So our final period is pi over 2. And again, because b is bigger than 1, what we get is horizontal compression. I'm not really interested in you knowing that if it's going to be stretch or compression. I just want you to be able to calculate the period. So here is a second practice problem. Please pause the video, try this one on your own. Okay, hopefully you got a chance to pause the video and calculate the period. The period for this example would be pi. Okay, so now we want to write an equation of sine and cosine given these values. And I'm gonna use color. Again, amplitude will be in red. I'll put midline in green for our k value, and then our period change, I'll put that in blue here. Okay, so just note that the general form of a sine function is y is equal to a, let me write a times sine of b times whatever your input is, x, theta, it could be whatever you want, okay, plus k. Okay, so in this example, we are told that our amplitude is 2. We are told that our midline is negative 12. So, actually, I don't know if I already knew that. Well, I do know I already knew that. So we're told that our midline, y equals negative 12, k equals negative 12. And then we're told that our period, notice I'm not writing b, our period is pi over 2. So what you have to do is you have to take pi over 2 and you have to find what b is. So if period's pi over 2, I know that period is 2 pi over b. And what I'll do is we'll cross multiply. Okay, so we get b times pi is equal to 4 pi. Well, if we divide by pi, we get b is equal to 4. Okay, so we have all of our values, so we get our function y is equal to, and I'm just going to plug in the values, 2 times sine of 4 times x minus 12. And there is your equation, right? It says equation. If it wants a function, then my y would turn into f of x, but it wants an equation. So that is the first example. Okay, here is example 2. So they want us to write an equation for cosine function with an amplitude that is negative 3.5, a midline of 72. That's a huge shift. And we have a period of 9 pi. So I have to calculate what b is. So I'm just going to make a note. Okay, so if period is 9 pi, I know that that is equal to 2 pi over b. So I'll cross multiply, which gives us 9 pi times b is equal to 2 pi. So again, I want to isolate b, so I divide by everything I don't want, 9 pi, divide by 9 pi, and we get b, so pi's cancel, we get b is equal to 2/9. Okay, so b is 2/9. Okay, so if I have the general form, y equals a cosine of b times x or theta plus k, I can just plug in my values. Y is equal to negative 3.5 cosine of 2x over 9 plus 72. There's your equation. Okay, again, it's just, very simple. You just plug in your values. And then you have to use your period, right, to calculate your 2/9, and then that's when you plug in 2/9. Okay, so please go ahead and try this practice problem, and then I want you to view the solutions. If you get stuck, talk to a partner, consult your notes, or maybe rewatch the examples. Okay, so hopefully you've had a chance to attempt the problem. Here is the solution. Since your k value is 0, you're going to have nothing added on at the end, right? You don't have to put the plus 0. If you do, you don't really have to. I wouldn't. Here's the second example. Please pause the video, try this one. Okay, hopefully you've had a chance. Here is the solution. Okay, so hopefully you are able to write an equation with sine and cosine given amplitude, midline, and a period change. So again, the period is 2 pi divided by b. If your period changes, you have to calculate b to plug it in. We'll go over graphing and looking at seeing how this affects graphs tomorrow in class. All right, so please get the assignment. Please try these types of problems that you did on today, and we'll continue the rest of the lesson mañana. Have a good day.